Okay, I'm going to start by redoing number 2. I found where I made my mistakes, so I do apologize for that. Alright, so the surface area, we said, are the 2 smaller faces, we're calling them 2x squared, and 4 of the rectangular faces, which is length times width, hx. We want to substitute in for h. We solved over here. If the volume is this, then h is 8 over x squared. So we have 2x squared plus 4x times 8 over x squared, which is 2x squared. Take that out, plus 32, x on the bottom, which I'm going to put as x to the negative 1. So let's take the first derivative of this. It's 4x minus 32x to the minus 2. Okay? Which is the same as 4x minus 32 over x squared. I'm going to set that equal to 0. 4x equals 32 over x squared. I'm going to cross multiply. 4x to the third equals 32. Divide by 4. X cubed equals 8. X equals 2. So the dimensions are 2 by 2 by 2. So it's actually a square cube box, isn't it? Okay, let's go here. We had started in the last video to get the first derivative, which was a. Now it says, for what values of a and b does it have a critical point here? Well, that tells us a few things. That means at x equals e, the first derivative at e, right, has to be 0. And the original function at e has to have a y value of negative 2. So we'll have 2 equations we can use. So first I want to solve this at 0, and that's when x equals e, right? So a, ln of e plus 1 minus b equals 0. ln of e is just 1. So this is 2a minus b equals 0. 2a equals b. And we're going to use that to put in our next equation. So let's take the original at e. So f of e has to be negative 2, right? So it's a times e, ln of e, minus b, we said is 2a times e, which is x. Okay, ln of e is 1. So negative 2 equals a e minus 2ae, all right, which is negative 2 equals negative 1ae. So the signs go away, and I'm trying to find a, so I'm going to divide by e. So a equals 2 over e. All right, and if I go back to b, b equals 2 times a, which is 2 times 2 over e equals 4 over e. So here's a, and here's b. I have a few more to do, so I put this on the next page too. It says, using your values for a and b, okay, we said a was 2 over e and b was 4 over e. Is the critical point this a local maximum, a minimum, or neither? So, alright, I'll look back for 1 second, and here is my second derivative. My first derivative, excuse me, looks like this, right? So if I take my first derivative at e, which is, let's see, a ln of x plus 1 minus b. No, well, we have a and b now, don't we? So a is 2 over e, and b is 4 over e. Well, we know at e, this is 0, so let's use our little, right? So at e, I'm sorry, this is 0. So what if I use, and e is about 2.7, right? So what if I check 2 and 3 to see what's going on? So f